Hello, and welcome to this video presentation. My name is Paul Brett. I'm a Senior Software Support Analyst supporting the Transformation Extender product from IBM. The topic for this video is using ITX with ActiveMQ. Feel free to reach out to me on popular social media channels at Paul Brett Tech. ITX can use the JMS adapter to connect with ActiveMQ, but there's also now a dedicated adapter. ITX 1101 adds additional connection options. We will review some of these in this video. I will also briefly mention the current limitations of this adapter, such as triggering via launcher. I'm starting my demonstration in the ITX 1012 Design Studio, and I'm going to drag in a pre-prepared map that is going to demonstrate the JMS adapter. As you can see, this map source file contains 4 maps. The first one we're going to look at is put message. On the input side, I'm reading a file, input.txt. On the output side, I'm using the JMS adapter with all the associated connection string options there, writing to a queue named testq1. Having a look in the directory, you can see that as necessary for the JMS adapter when connecting to ActiveMQ, we need to have a jndi.properties file. This is defined to show that testq1 is actually q.testq1. Okay, I have a remote view to a virtual machine here where I'm running ActiveMQ in this command prompt here, and here is the admin page which shows that I have a queue called testq1 and there is currently 0 messages in it. So let's build and run this map. I can build it in the Design Studio, but I cannot run it in the Design Studio because the Design Studio does not effectively run maps that use the JMS adapter. So I'm going to run it in the command prompt instead, using the command server. Here is my command server string and the map I'm running, and -bi at the end to close the command prompt window if the map is successful. The map has finished executing. If we go to the remote view of the virtual machine and refresh this page, you will note there is now 1 message on the queue. So let's go and use this put 100 map. As the name suggests, it's going to put 100 messages on the queue. That map has completed successfully, and the remote view of the machine, when refreshed, will now show 101 messages on the queue. Let's have a look at the get message map. You can see that I'm using the JMS adapter on input, and the on success option is set to delete. On the output side, I'm writing to sync, so I'm just dequeuing messages with this map. The map has finished. Remote view from 101, once refreshed, will now show 100 messages. So we've dequeued 1 message. So there we go. That's a quick demonstration of the old method of interacting with ActiveMQ using the JMS adapter. As I say, a couple of disadvantages. Can't really run it properly in Design Studio, and the jndi.properties file has to be updated to include any queues that you want to use. Let's move on now to the equivalent with the ActiveMQ adapter. Here we are in ITX 1101 Design Studio, and as you can see, I have a project called ActiveMQ versus JMS. Within that, I have a map source file called ActiveMQ, and within there are 4 maps. So let's work with get message first. I'm using the ActiveMQ adapter. Here I am passing a URL pointing to my ActiveMQ installation, telling it to use testq1 again. I'm putting in a delay timer for 5 and a read mode of delete, telling it the message type is text, and I'm turning on adapter tracing. Quick reminder, the admin page still shows we have 100 messages on the queue. So when I build and run this map, and you will note that I can run it in the Design Studio, Once the map is complete, we look at the remote and refresh, and we now have 99 messages. So I've successfully dequeued one message. Let's have a look at another map here, get message with HDR. Now this is one of the new features of ActiveMQ, allowing you to get the headers. The JMS adapter did allow you to get headers, but would not allow you to put headers, which is a key point, which we will come to later. So we're going to get from ActiveMQ. Here's the connect string all again, and I've got -HDR1 here to retrieve the header. The file I'm writing to is input.txt. So if I build and run this map is now complete. If we look at the remote session, 99 messages, refresh, we're down to 98. Actually, we're not down to 98 because I forgot to put in the read mode. It's my fault. So let's go into read mode and add in delete. Build and run one more time. The map completed successfully again. This time, hopefully, when we refresh, it will go from 99 to 98, which it does. Let's have a quick look at input.txt file. Here it is. Here's the complete header of the message, as well as the data, which is at the end in the payload section. I'm going to use this file for a put message with header in a moment, but you will note that there is a destination queue included in the header. Now, as you specify the destination queue in the adapter command line, and this is mandatory, you cannot also have this section of the message in here. So I'm going to remove it and save this file, and we shall be using that again in a moment. Let's have a quick look at the put message. I've used a put adapter call. This could just as easily be in a card. As you can see, I'm writing to test Q1, message type text, putting in the word hello. When I build and run, looking at the remote view, we go from 98, and when I refresh, back up to 99. Adding another message to the queue. So let's have a look at this put message with HDR now. On my input side, I'm reading the input.txt file that I created earlier with a get message with header. Bearing in mind, remember that I had to remove the destination. Again, I'm doing a put. This time I've also had to add -HDR1 as part of the adapter connection string. And my payload, instead of a simple hello, is my input card structure, which is the JSON that I mentioned earlier. And because it is JSON, you could actually use it as a schema, and you would get access to the individual parts of that header. And same on retrieving a message. You can use the JSON as a schema to map individual parts of the header. Let's build and run this map now. Map completed successfully. And now the remote view shows going from 99 to 100. Okay, so that's the maps in the Design Studio. Let's pop over to Design Server and show what options are available there. It's worth mentioning that with the ActiveMQ adapter, although you can use it in Design Studio and Command Server, it is not possible to use it in Launcher, as it is one of the newer generation of adapters that does not have an associated adapter ID, and therefore is not available for use with Launcher. Here we are in the ITX 11 design server, and as you can see, I have one project called ActiveMQ. In this project I have a map called ActiveMQ Get, and within here we have an input card and an output card. My input card uses a blob type tree, and the settings show that I'm using an Apache ActiveMQ adapter with roughly the same connection string. I'm getting a message from test Q1, message type is text, read method is delete with a delay time of 5. On the output side, I'm also using Apache ActiveMQ. The queue name is test Q2 with the -CQ option to create the queue if it does not exist. Quick reminder, remote view, we have 100 messages in test Q1 and we do not have a test Q2. If I build and run this map on Design Server, The map completes successfully, and on the remote view, when I do a refresh, you will see one message removed from test Q1 and a new test Q2 has just been created that now has one message on it. So this map is moving messages from Q1 to Q2. Also in the design server I have a flow called ActiveMQ flow. I've dropped the map ActiveMQ get, and on the input side I've set enable watch. Going back to home and into packages, I have a package called package 5. You will note that it has included within it the flow ActiveMQ flow, and when I deploy this package to my local runtime, before I deploy I shall just show that it is not currently deployed. I will refresh, nothing is deployed. If I now deploy that map, the map is now deployed as a flow. Here we can see it as an endpoint. And if I go to my remote view now, in theory we should see all messages removed from Q1 and moved to Q2. There we go. It took 3 refreshes, but they got there in the end. All messages have been removed from Q1 and they're sitting on Q2. And every time I put a new message into Q1 now, because that listener is running, which I set on the design server back in maps, in the flow, this is where I enabled the watch. When I deployed that, that set up a listener so that every time a new message is sent, currently 100, I'm going to use my old map to send one more message. There we go, one more message on test Q1. When I refresh, you will note that the message has actually arrived on test Q2. There we go, we have 0 and 101. So although the message arrived on test Q1, my listener that is running under ITX 11 has seen the message, picked it up and moved it to test Q2 for me. That's the end of the demonstration. I hope you can successfully move any JMS maps that you have created to the ActiveMQ adapter, and it allows you to migrate to ITX 11 and use the flow server to listen for, pick up and process ActiveMQ messages. I want to thank you for taking the time to watch my video presentation today. If you found the content interesting and informative, please hit that like button. Consider subscribing to my YouTube channel, as I release content such as this on a regular basis. Feel free to reach out to me on popular social media channels at Paul Brett Tech. Thank you.